My name is Yuri, as Habit already said, and today I will talk why you should think more about the problem of LLM content detection and what it means in general. And that starts the small bio about me. I have a bachelor's degree in computer science and have 5 years experience in Python and 4 years experience in machine learning, and especially I usually work with natural language processing domain, and to date also focus on NLP domain. And we talk about text and without any images or other domains, so LLM content today is only text. Yeah, I moved to Armenia 2 years ago, and yeah, how is a lot of locals said me, I'm an Armenian already. Let's check it, but yeah. Yeah, about my work experience, I start my career in Sber devices, where I will work with also AI assistant and LLMs technology, where we work with chit chat and contributing to chit chat model of AI assistant of Sberbank. After it, I moved to Armenia and already can work in 2 places. One of them is Polexis, where I work with compliance and risks in fintech. And the second and more interesting place that I work now, already half of year I work in SuperAnnotate, and they help me to create this presentation and provide the interesting tasks and challenges for me. Also this about detection LLM content, and yeah. So I think we can go next and understand what it means, what is LLM content, because sometimes, yeah, you can think that it's images or not. Today we'll talk only about text. And LLM content, generated text or synthetic data, today on this scope of talk is the same. It's like synonyms, and yeah, usually you can understand it's text generated by GPT or in other LLMs like Llama. And understand what is the problem of LLM content. And maybe one or interesting parts of this content. LLMs sometimes have some hallucination. Maybe you already heard about it. Can have some inaccurate data or provide your answers that's not really true. For example, you can check this one. Maybe I use some tricks for generate this text, but ChatGPT says that the current Armenian president is Joe Biden. So sometimes, yeah, you can face it very strange things with generated text. And also, one very important part of generated text is speed of generation. So if you would like to write some text, you should spend more time if you are, I don't know, use some prompts and ask to GPT to generate a lot of text for you. So it's open a lot of maybe opportunities how to use GPT, and it can be a problem for our community and for people in general, and can have some risks for different sectors. So let's understand which sectors are at risk. And yeah, in the first, in SuperAnnotate, for us it's a big problem, and why we start working on this task. It's synthetic data for machine learning models, because it's sometimes not very good to use generated data or synthetic data for your training, because this data already contains some bias of base model that you use for generation. And also it can be a bit different of real life. And especially it's a big problem when you would like to train or fine-tuning your LLM with data generated by this LLM. Yeah, it's a big problem because it's show you only degradation of your model. So we should exactly understand which text was generated by model and which written by human. Because yeah, for training it's critical moment. And the next other sectors that can have some problems, it's cheating in education or science. There was also maybe already heard some cases when some scientists release about 1 paper in 1 month. It's unreal, but they use LLMs to generate their papers, and after it, their content is not very good, because I think all of us would like to read papers that contain maybe some ideas of the scientist, but not the generated text. And also for education, it's broke the general idea of education. If you every time use GPT to, I don't know, pass your exams and after. And also, a lot of other sectors cannot risk because, as I already said before, you can maybe generate text faster than write by yourself. So I don't know, you can, in the 2 seconds, generate a lot of phishing messages or something like that. So maybe my general point is that we need to have this opportunity or detector how to understand this text was generated or not. And yeah, small business requirements for me when I start working on this task on my job. I should maybe have or train this detector, and the main goal is generated score. It's very important because maybe if your return only predict like generated or not, it's not very good results for us because we would like to know some score, some probability of text was generated or not. Because sometimes maybe text can contain both of type of texts. It can be semi-generated or parts of written by human and generated text. So here we would like to see some score, some number, not just answer. And let's understand a bit more about this task. Maybe in the first layer, you can think that it's a really easy task because it sounds like binary classification task, so generated or not. It's true, but you can face a lot of pitfalls if you start working on this task. The main maybe reason of pitfalls because you have a lot of different tasks of generation tasks. It's mean maybe what's the reason and what you're generated by your model. It can be just text, or it also can be code. It can be maybe small text like image captioning. And you have a lot of different texts, so it's different sizes and different domains. Maybe it's, I don't know, for some special text for medical domain. And when you have this huge maybe amount of different data, it's very difficult to train your generic predictor that can work with all of this type of text. But yeah, I will try and have some results in this. And one more proof that's problem of detection generated text. It's very important. That's a lot of competition already started about this task. The second one is maybe more popular, and maybe you heard about it. It's a Kaggle competition. I think it's already finished 1 or 2 months ago, but it's the main competition at Kaggle during half of previous year, and a lot of scientists try to maybe create their detectors, but this competition sometimes have some problems that they close in some narrow domain. What I mean, I said before about different types of generation, but this competition focused only for educational domain and only for students' essay, as I remember correctly. So it's very low parts of big problems. So if we are maybe have detector to determine the students' essays, it can be helpful in, I don't know, in your data, your training data for email. And also, semi-eval is more interesting, but it's not finished, and we don't have any results here. But I believe that this competition gives our interesting results and new approaches in this task. And a lot of other competition. And one more point, and maybe what's the problem of this competition? I already said that it's narrow domain, but also Kaggle, maybe you don't see very good this slide, but I said what's happened here. Kaggle competitors usually work only for maybe give highest score or maybe the highest place on your leaderboard. And they focus only for it. It's, they don't think about how many resources they spend. It's not applicable for real development environment. So, for example, this picture shows that here you can see 10 different models. It looks like leaderboards, but it's not. For real, it's a winning solution. So winner of the previous competition that I said about Kaggle competition, winner solution, it's ensemble of 10 huge models. I can imagine how I can maybe use it in real life. I don't know, I should use 10 AC2 instances and spend a lot of resources only for detect educational essay. I think, yeah, it can be helpful for us, only some ideas, but they only work for results and not for real development area. And now, yeah, I would like to say a bit more about different approaches and in general, how you solve this task, how maybe which methods you can use for train this detector. And here only 4 different approaches that I think is more interesting for me. And the small spoiler, I only use the last one. The last one, it's LLMs, no. LLMs, it's small mistakes here. It's just LLMs for detector. So it's just fine-tuning your language model for detection. Language model, it's not large language model like GPT. I said about BERT-like models with special classifier layer above. But yeah, exist a lot of different approaches, and now we try to understand maybe what's the logic of these approaches and why maybe and where the disadvantages. And let's go step by step. In the first technology, it's more interesting for me. This name is watermark technology, and I think it's the best solution ever. And in the future, I would like to see the solution everywhere. The main idea is like watermark. Maybe you know already what it means. It's moved to this problem from watermark on images. So idea here is maybe in the image you have special watermark. That's after it you understand that's maybe source of this image, maybe who creates this image. And the same idea in text for LLMs. They have special algorithms for your generation. That's after it, for human, it's very difficult to understand that this text was generated. But after you use algorithm and calculate some probabilities of your tokens in output sequence, like this, you can understand that the sequence was generated by model. But the main problem here, maybe this solution sounds very good. You can solve all our problems. But it's ball on court of LLM developers. So they should integrate this solution to their generation process. And now we can affect to this, only wait while maybe OpenAI starts working on it, and after it open source this algorithm, how we can determine. Maybe they do it already, but now we can only use other detectors without their support to determine what text was generated. The next class of methods is zero-shot, but it's very general name of zero-shot. It can be really different approaches, but here I would like to concentrate of detect GPT. It's a quite popular solution or method for detect this text, but also have some disadvantages. They have very good results, and one problem of this solution, they work like the hypothesis of that exact text was generated by exact model. What does it mean? For example, I should maybe understand that correct text was generated by, for example, ChatGPT. And only after it, I can maybe test and check this hypothesis. But if I don't know which LLMs can user use before, I don't know what I can do. I can check every open source LLMs. It's unreal. So it's very difficult to understand which LLMs users used. And I think we can use it for maybe in general and basic detector when users can use any LLMs, open source or APIs or anyone else. But yeah, idea here, I missed to say it before, with also one problem to use LLM, inference of LLM. So you should add perturb for your sequence. Maybe I can a bit zoom it to see the idea. You have the original sequence. After it, you perturb from another. And here is an example. They check the hypothesis of text was generated by GPT-3 and also rewrite text by T5. So yeah, maybe it's spent less resources, but anyway, it's inference of LLM, and it spent a lot of time for it. And also one problem of this method, I also have linked to the paper, that in the paper they tested only on weak LLMs, like GPT-3, GPT-2 Neo, and something like that. But no one about maybe newest and current state-of-the-art LLMs like Llama or ChatGPT with GPT-4 version or something like that. And the last approach that I maybe didn't choose when I understand what approaches exist now, it's LLMs as detector. So my main point of LLMs now, it's very good for generation text. It's very good technologies now. But you can't use it for low domain tasks like classification. It's really strange thing, because the main idea to generate text, not to classify something. And you spend and overhead a lot of resources to check use LLM as a classification model. And so I think it's a very good proof why you don't should use LLMs as detector. Maybe LLMs as detector, maybe I don't say it before, it means that you just ask prompt your GPT that you generated text or not. And the next, we already said about open source, but I should also say it about our solution that we chosen to fine-tune LLMs for detector. For me, it's more simpler task and familiar for a lot of developers. So we already a lot of time use BERT-like models for classification. It's show us the state-of-the-art technologies because it's usually beat a lot of different models and approaches of classification task and spend not a lot of resources. So it's the main reasons. And here, I would like to show some approaches that I comparing. What you can maybe use now if you don't train your own detector. It's more popular open source model and APIs. Maybe you already heard about some of them. Here's some of them, and I think if you're really interested in this topic, after it I will publish the slides and all of this, it's links. You can maybe open and use these detectors for yourself. But I would like to show one problem of all open source solution. It's these distributions. And let's understand what is happening here. I need to zoom it again. It's distribution of generated score, as I said before. So when you train your model for classification, for the output, you don't have the correct prediction. You usually have the probability. So in this, it's distribution of generated probability. And what's happened here? All of detectors usually overfitting for overconfidence. So they never have some maybe problems or faced some semi-generated text. Every time they overconfident, maybe it's exactly human text or exact generated text. But in real life, it's not true sometimes. And it's also my very big aim to train model that have this very good probabilities of generation of generated probabilities. So it's the good distribution of probabilities for me should something like this. So when your model sometimes have, I don't know, say it, I confidence that 20% that this text was generated. I think it's very good when you have some maybe middle answers, not overconfident or maybe exact answer in the output. And let's go next and discuss what I should do for train this model and how I avoid this overfitting, and maybe how to check after it that my model it's maybe have these good probabilities of confidence. In the first, if it's regularization, it's really simple, and I think if you are already trained some models, you know some techniques how to work with regularization. It's general ideas of wave decay and labeling smoothing. And I don't do maybe deep dive in these approaches, but I would like to highlight a bit on others, especially for this task, the difference of general tasks for classification. It's indicating words. What does it mean? We have trained data, and sometimes in this data for models we have some special indication n-grams, for example phrases that's generated only by model, or maybe only human writing like this. For example, hello, I'm assistant. For example, something like this. Its phrases give you this overfitting that I showed before on distribution of probabilities. So to avoid them, we need to indicate these phrases and grams and remove from your training data. How to indicate it? It's usually you can use any approaches like key test, key square test, or correlation with your labels, and yeah, indicate these words, phrases, and remove them. Yes, in the next, that I already said, the very important part is confidence, and here this bar, I think maybe, I believe everyone knows what it means, but I say it again, it's calibration bar. Here is probability range. Yeah, here is probability ranges of your output of model, and here is percentage of labels is really 1. It's like accuracy. So you need to have in the output of your model, for example, when your model return you some probabilities range from 0 to maybe from 0 to 10%. Maybe you expect that accuracy of really percentage of labels is 1 is something like 0, or in the same range as a probability, the same range of percentage of your labels. So maybe perfect situation with when you have this triangle as a red line. But our solution has these plots, but it's already very good, because when you have something like full square, it's a very bad solution. It means you overfit your model and you can't believe your output probabilities. And one more thing, we already I already said about the domains, that we have different domains like medical or education domain or scientific. But if you aim to train your own model, you need to understand what's maybe from what domain you have texts. For example, if I focused only for education, yeah, for real, I don't need a lot of data for my trained model. I have these experiments and research for this direction, and you need, I think, 100 or 200 samples, maybe human written samples of this domain. After it, by using any LLMs, you can generate the generated version of text, and after it, you already can train your model, and you need only have, I don't know, 1,000 of items, and after it, you already can have the good model with some regularization, the same way to a lot of training, but you can have already good detector for your domain. So you don't need to maybe gathering all internet like LLMs. You don't need this pre-train, but only focus on your narrow domain. It's the main idea. And here's a benchmark that we collected together in my company. Let's in the first a bit discussed which domains we have inside this benchmark. We would like to have it's a bit generic. So we include different types of data here. In the first column, it's Wikipedia. So we take the original articles from Wikipedia and ask to ChatGPT and other LLMs to generate the same articles. It means maybe not paraphrase the original article. We provide in prompt only the topic, and please write the Wikipedia article for this. And Reddit QA, it's a special data set from comments in Reddit when people ask some questions, and so it's question answering data sets. We extract data from here. It's some special SuperAnnotate instructions. It's our internal data set. So I said before that we work with some data sets for our customers and help them for annotate data, also for fine-tuning LMs and LLMs. So they have a lot of these data sets like question and answer, and we collect for our own subset for includes to this benchmark, because for us this number is more critical. Also, we include papers like scientific or educational domain. I think they're really close. And the code, because yeah, it's really have big difference and a lot of solutions that we discussed before. So Hello, Simple AI, Vicuna, GPT-0, and Journality, they didn't have any expertise with code, but it's also can be a problem. Maybe you can already face it, the GitHub repositories, and you would like to run this code and understand that nothing is working, and after it, you know that this code was generated by LLM, and it's really, it's look like the good GitHub accounts, but for real, it's just generated code, and nothing is working. So yeah, and here is some numbers, and we beat all others competitors in this small competition of our internal competition. For real, it's not maybe really truly results, because I have the same data in my train for my train, but I don't have some intersection between data in train for model and from benchmark, but they have the same domains. But for example, you can see that a lot of problems of open source solution in the code because they don't focus on them. But my idea is to create this generic predictor that can determine any domain and any text. And yeah, it's a small spoiler about our solution. We decided to release it in near future. I think in the maybe first parts of the next week we already open source and open source our model, so anyone can take it and use or fine-tune for some reasons and fine-tune for some narrow special domains. I think it's also the big advantages of generic model that you can take it and after it one more fine-tune to some narrow domain. It's maybe show your better results if you start fine-tuning just a LM like BERT without any previous step of fine-tuning for detection task. And also we provide some Git repository with service. It's especially for integration for our platform. But anyway, it's repo can help you to create your service, HTTP service, and maybe read the tutorial and just deploy for, I don't know, anyone you want, maybe on your laptop or instance, and you already use this detector for your reasons. And yeah, I think it's a good place to say that every scores and metrics that I showed before on benchmark, they have about 90% of accuracy. It sounds very good, so we can determine 90% of data determines the real after, so it's generated or not. But for real, we can fool the detector. It's regarding my detector and all other open source detectors or APIs. You can use some tricks or special prompt instruction to fool your detector. So the highest improve. Maybe here on this table, you can see there that's the more reduction from spelling errors. So yeah, you ask your model to provide text with spelling errors or add for yourself, because yeah, usually detectors trained by real data, real generated data. By generated data don't have any mistakes or errors. Mistakes, I mean grammar or something like that. And paraphrase, it's also very good. You can ask your model to paraphrase this text a couple of times, and it's also maybe big problem for our detectors, because for example, in my research, when we train the data and generate data for training, we only use straightforward prompts. So ask maybe straightforward. So I have some topic of Wikipedia about, I don't know, some political person, and I would like to, and I ask in prompt some models to generate a Wikipedia article for this person. I don't ask some cheats like this, but I think if we use these cheats also for generate data for your training for detector, and it can help, and maybe this reduction can be less. But now, unfortunately, I think no open source model on APIs don't think about the maybe fooling detectors, and only focus for maybe the straightforward approach. And also, yes, killer feature of fooling detector is generate as not native speaker. So yeah, you can ask your model to generate some text like your speaker of any other countries, not the English, and it's also a big problem for detector to determine who is after of text, because usually these problems with not speaking usually only real users, but not the models. Everywhere I also have these links for papers, and you can read more information about these approaches and methods. And yeah, I think it's all. I don't know, maybe have I my time and deadlines, because I'm a bit nervous, but I believe it was really interesting for you. I appreciate for your attention for my talk, and now I think we can maybe have this question answering session, and yeah. If you have... As I understand, if you have any questions, you need to raise your hand, yeah, and face the microphone.
So I wanted to ask regarding the LLM models you used in the sample data. So basically you used the GPT-3 to generate the sample data of 1,000, but have you used any modifications like temperature parameters changing or K parameters changing in your sample data? Or was it just straightforward, like asking for synthetic data for GPT?
Okay, I think I can repeat your question because not anyone can hear about it. As I understand your question correctly, you ask about which LLMs we used for generate our training data sets, yes?
Also the parameters like of LLMs, like K parameter, like temperature parameter. Okay. So have you played with that in the sample data?
Mm-hmm. Yeah, thank you for your question. For me, when I generate data for my training, I usually also use GPT 3.5 and GPT-4 without any parameter tuning. And also, I should take my training data from open source datasets. They also have already data from different models. For example, in my training data, I have the same domains like in benchmark here, and here, for example, papers. In papers, we have, maybe I take the open source datasets. They contain some text generated by special models. Its name is Galactica. It's especially for papers generation. And so sometimes we have some different models, but in the first we focused on ChatGPT because maybe the most part of people usually OpenAI just at all. And one more thing that I would like to mention here, that's for real in my research, I checked from different models also, but ChatGPT usually have good generalization of all other LLMs. Maybe they also use some maybe same generated data by GPT, and after it used for their pre-train, but they have the similar idea, and you can generalize all maybe major parts of LLMs by using only text generated by GPT. Here.
Thank you. I have one pre-question. Do you have experience working with Armenian words?
With Armenian? Yeah. Repeat question again. Yes. Question is use any Armenian in my experiments, and the answer is unfortunately no, because we focused only for English and we didn't have any experience with other languages.
Okay, thank you.
Yeah.
Thank you. I have a question about this train test splitting. So, am I right that these results are on your test data and train data were generated by these all LLMs, and not in that way that your test data contains only examples generated from one LLM on what your model was not trained?
Okay, I believe I got your question correctly.
Keeping one model just away, and you are training your model on like using three models, and then you are testing your model on the p-hold, like hold-outed test, something like that.
Yeah, about maybe as I understand, you mean I use this benchmark for validation, as I understand correctly your first question, and the other is regarding the models. It's the like same which models I contain in my.
No. It's about only your test data. Like test data, if test data contains examples only generated by LLMs that you didn't use in your train data.
No, I said it's the same distribution, so it's the same
data
sets for train data and for test,
okay,
but they don't have any intersections. So I don't train my model in this data and after it validate. No. It's a different data, but in the same distribution.
There were no such experiments that I have just described. Just you are keeping one model away, and then you are testing only on this model. Thank you.
My question is about real text. As I understood, you have generated some text in different LLMs and you have labeled it as generated. And what about the real text, not generated? What the confidence that this text is not generated, that this is real?
Yeah, I think maybe it's a reason that I'm nervous a bit and sometimes I said something during my talk. So I think I should say more about how we maybe collect this data set for training. In the first, it's like step by step. In the first, you should take some human writing text. So it can be, for example, text from Reddit, from comments in Reddit, or from Wikipedia, or any other resources. So you already know that it's text written by human. And after it, you try to find some ideas how to create prompt for this text. Maybe, for example, if it's a Wikipedia article, you take the topic and ask LLM to generate article for this topic. So yeah, in the first we collect human written text and label it as human. After it we ask to models already take from open source data sets generated ones or generate for ourselves with some special prompts.
And what about code? It's a little bit different because code has some structure, and it is remains when the people write this code or the generator write the code. And what is the confidence that the code is written by a person, not by?
For code, we only use already open source data set. That's maybe I said about our release in this page of our model that's released. I show the all open source data sets that I extracted this data. And for example, here is open source datasets that's named Evolve-Instruct Python. So they also have and contain these samples. That's in the first, as I understand, they extract original human written code from GitHub, understand maybe by your documentation what's the reason or idea of this code, and after it, with these snippets of documentation, ask your model to generate this code, maybe the same.
First, thank you for interesting lecture. The question is it possible to add interpretation to your model? Like not only predict this text is generated with probability like 70%, but also this part of text is the main suspect to be generated.
Yeah, it's interesting idea. Thank you for your question. The first, yeah. Can I show this open source solutions? Also, open source have some experiments with that, and I also have experiments. The main idea is to train your model not with full text, by sentence, and after it you can predict and extract exactly which sentence have maybe the highest risk that this text was generated or not. So it's a parse. But actually we didn't have very good results on the small sentences or maybe 1 or 2 sentences. It's not enough maybe amount of data to detect this idea of generation, because usually for detect generated text you need more sequence token to maybe understand it. But anyway, for example, GPT-0 have this feature also, but maybe I tested it and I think its accuracy, it's really low, about 40% of accuracy, and it's without any cheating that I said after, maybe tricks how to fool your detector. Yeah.
Thank you for your presentation. I have my question is more based on business analytics. I mean, it's a question more, I guess, directed towards business analyst type of question. So my question is, have you been seeing sort of a trend of what industry that LLM is being more in demand, or do you see a trend happening that is certain industries going to ask more and more of it in the coming years? I mean, is there, for example, for example, LLM is being applied a lot with customer service chatbots, if I'm not mistaken. As one example, do you sort of see a trend where LLM is going to be more in demand? Is it going to be, does that question sort of make sense?
Yeah, as I correctly understand, you mean maybe some gender of LLM.
Is there a certain industry, do you think that will have more demand with
technology? Okay, I understand. As I understand your question correctly, you ask about some trends of LLMs if they generate a text have some bias of no?
Yeah, so for example, is this something where maybe governmental related organizations will, do you see a trend where maybe governmental organizations will have more use of this, or is wanting to have more use of this technology, or is it maybe mining, for example, the mining sector wants you'll see more use of this technology being used? Does that make sense? If not, I can ask you afterwards.
No, I understand, but I try to think about what the trends of using LLMs, but I think maybe in this my research I usually focused on the text for instruct-based LLMs generation. So when it's work like the chatbot and just ask for direct questions, but the global trends I maybe don't remember any. I maybe notice that have maybe big bias to some domain.
Okay.
Yeah. Okay. Thank you for your question.
I would like to know your personal opinion about these detectors. So given the fact that the LLMs are getting smarter, there are advanced prompt techniques and the parameters that are annotated. What do you think? Would it be possible to create a detector which will detect all kind of text generated by all kind of advanced like prompt?
Yeah, it sounds very good. Maybe anyway, LLMs anytime have some updates, and you should also update your detectors. So you need to have the same speed of releases and maybe use newest data for detect. But my opinion is this task can be really solved as well if LLMs developers start to use watermark technologies, as I said before. Because now when we try some detectors, we can't maybe guarantee some big amount of quality of your detector, because sometimes you can maybe avoid some models, because now it's a lot of different LLMs with some custom fine-tuning, and they have maybe sometimes can have big difference. And so create this maybe killer generic detector is very difficult now. You only can maybe, the best way is cover your domain that you would like to maybe work exact and which models you work. For example, we usually use it for check our annotators, and we know that they usually use a couple of models. That's major part of people. It's GPT OpenAI or some maybe Bing, because they didn't have resources to start, I don't know, some 70 billion of llama and generate for your routine needed. It's strange. So yeah. Thanks. Here's one more question.
Hello. I have a question regarding using LLMs for detecting LLM-generated text. So at your slide, you had some really big numbers, like that you need to spend a lot of days and a lot of money to, yeah.
Here is a big note that's maybe it's priced for one client. One client, it's usually 100 or 500K samples with 2K tokens.
So could you please tell a little bit more what is like a sample and what amount of data do you have during those requests?
It's not maybe problem which data you have or what is the samples exact. It's just one sample contain 2K tokens, maybe tokens of text that's input for any LLMs. And after it, you can this amount of samples, and it's not important which data you use. It's only important this amount of tokens. And after it, if you would like to inference your model for this amount of data, you need to spend this times and this money. For example, for OpenAI models, these numbers calculated by their prices for API, and for Llama, it's amount of maybe the price for maintains your instance for inference your model. So it's really a lot, I think. So we not ready now to use LLMs for maybe low and simple task, because it's need a lot of resources. Usually maybe for your generation is good, but for classification I think it's not ready now. At least not ready for production. Yeah. Thank you, sir. Here one more question.
I don't know if it's a question, more like an observation. So I definitely see the use of this technology, like to detect trolls on Twitter or on comments. But other than that, I think the using LLMs as content generation, especially text, will be more useful for people, and they will use. For instance, we're having clients when the tool is to help journalists use LLMs for faster producing content. So basically, you just give facts, and it gives you nicely made article. So it's LLM generated, but it's a kind of it's not bad. So the question here is like how much LLM is hallucinating and fact checking. Yeah. So that's the real problem. So can you like elaborate on that? Did you think about like fact checking as well, or is just detecting if it's a LLM or not?
Yeah, thank you for your question. I'm totally agree with you that sometimes generated text can be helpful and it's speed up your maybe help in your routines. But maybe my main point that people should know that this text maybe while this text was producing, they use LLMs technology. So it's just a mark, a note in the last maybe in the end of news that they use, and you already can maybe think that okay, maybe some of the data is inaccurate. And also, yes, maybe if you have some review after it and change some maybe words or paraphrase something, this detector is already maybe difficult to determine that its text was generated because it's already mixed text. And we also maybe need this label and this information, this text was mixed. But when we don't know anything about text that we can spend or face it in the internet, it's I think it's bad because you can maybe take this risk for you because you don't know the author of text, and you you can't believe the author in the text, because hallucination it's maybe not every prompt or every completion of LLMs have hallucination, but you have this maybe probability of this, you face it. So you need to have review and need to know, I think. Yeah. Yeah, I think so. Anyone else?
Okay, thank you.
Yeah.